right, so we're going to calculate this one twice. We're going to do it firstly using a binomial, the actual calculation. And we're going to do it secondly using the normal approximation. So when in the actual question, they've asked the probability that less than 9%. So 9% of 50 is 4.5. So less than 5% is up to 4. So that's why they've stopped out at 4. So for A, Px is less than or equal to 4.5. So Px equals 0 plus Px equals 1 plus Px equals 2 plus Px equals 3 plus Px equals 4. Oh, I'm already wanting to use the normal approximation instead. I'd much rather look at a table than calculate these. So we have n equals 50. P is a half, heads or a die is thrown 50 times, the result will be a head. I'm assuming they meant coin. Otherwise, I mean, if we want to assume it's a die, then P equals 0, yeah? Let me double check what they've done in the answers. They could have just been a total smart aleck. No, they've... The number... No, the... Okay. In the work solutions, you can clearly see they mean rolling a 6. So here the probability is not going to be a half, it's going to be 6. And instead of hairs, it's going to be 6s. Sorry. Okay, so anyway, we've got 50c 0 times 1 on 6 to 0 times 5 on 6 to the 50. We've got 50c1 times 1 on 6 to the 1 times 5 on 6 to the 49. We've got 50c2 times 1 on 6 to the 2 times 5 on 6 to the 48. I'm not going to do the rest of this. You can do this. The answers are in the book. Okay, question B. Using a normal approximation to the sample proportion, find the probability P less than or equal to 0.09. So, the mean of the sample proportions, we can safely say, is NP, which is 1 in 6. We can't say it's NP because it's just a sample proportion. The standard deviation for the sample proportions is the square root of PQ on N. So here we've got the square root of 1 on 6 times 5 on 6 over 50. So it's the square root of 1 over 360. I'm just going to leave it like that. Let's say x equals 0.09. We're going to find the z-score because we're normally distributing it. That's the only way to kind of solve these using a table. So the z-score for this one is 0.09 minus the mu, which is 1/6, over the standard deviation, which is square root of 1 on 360. So we're looking for a z-score of minus 1 on 6 over square root of 1 on 360, negative 1.45, which looks reasonable. All right, let's have a look. Z-scores. Where's that table? And we wanted 1.45. 0.9265. So the probability that Z was less than or equal to, 9265, and that's looking at the tail, yes, to the left. Negative 1.45. So that's, I've already forgotten. 9265. So PZ is less than positive 1.45 is 0.9265. If we were to draw this, here's the mean. Here's a positive 1.45. And that's all the ones to the left. What we want is the negative 1.45, and all the ones to the left is of that. That is the same area as what's to the right of positive 1.45. So we can say PZ less than or equal to negative 1.45 is the same as PZ is greater than positive 1.45. So that's 1 minus PZ is less than or equal to positive 1.45. So it's 1 minus 0.9265. Don't know if you guys can see that. 1 minus 0.9265. 0.0735. Which is roughly 7.4%. Ish. Which if we'd done this calculation we would have something to compare it to, but I was too lazy.